This is part 6 of LINQ tutorial. In this video, we'll discuss restriction operators in LINQ. The where standard query operator belongs to restriction operators category. Just like SQL, the where standard query operator in LINQ is used to filter rows. The filter expression is specified using a predicate. Let's look at an example. Let's flip to Visual Studio. Here I have a new console application. At the moment, we've got this numbers list which contains numbers from 1 to 10. Now let's say we want to retrieve only even numbers from this list. To achieve this, we can use the where extension method and then specify a lambda expression to retrieve only the even numbers. A number is said to be even when we divide it by 0 and when the remainder is 0. And if you look at what this where extension method is returning, it's returning I enumerable of integers. So let's create a variable of type I enumerable of integers and let's call it even numbers. So this variable is going to store all the even numbers. Now let's use a for each loop through each integer in even numbers collection and then print the value of I. So now when we run this program, as you might expect, all even numbers should be printed. Now from the IntelliSense, notice that there are two overloaded versions of this where method. And if you look at what this method expects, it expects a parameter. Look at the name of the parameter, it's called predicate, and its type is func int comma bool. So what is this func? Let's investigate that. So right click on the where extension method, go to the definition. First of all, notice that there are two where methods because there are two overloaded versions. And if we scroll all the way up, notice that these methods are present in enumerable class. Now if you look at this where extension method, within the enumerable class, when we look at the signature, notice that this function has actually got two parameters. But then within program.cs file where we are actually using that extension method, from the IntelliSense, notice that it only shows that it has got one parameter that we need to pass. Why is that? That's because this where method is implemented as an extension method. Okay, and what is the rule of extension methods? We discussed extension methods in detail in the previous sessions of this video series. Now there are two rules for an extension method. Rule number one, the first parameter should be the parameter that this extension method is extending. Now in this case, this where method is extending I enumerable interface, so that's what is passed as the first parameter. And what is the second rule? The second rule is the parameter should be preceded by this keyword. So this proves that it is implemented as an extension method, and since it's an extension method, this first parameter is the type that we are extending, and the second parameter is what actually we need to pass to the method. So what is this func? If we right click on that and then go to the definition, notice that a func is actually a delegate. And what is a delegate? A delegate is nothing but a function pointer. So essentially we have to pass something here which resolves to be a function. So it can be in the form of a lambda expression like this, or you can pass a func explicitly, or you can create a function and then pass it as an argument. Okay, so since we have to pass a function here, this is a lambda expression. If you look at this lambda expression, first of all, notice the type of func or the function that this where method expects. It has got two parameters, int comma bool. So what are these parameters? Now when we actually go to the func declaration, it's a delegate, and look at that, the first parameter, it's a generic delegate. So the first parameter is an input parameter, the second parameter is the output parameter, and the first parameter type, it's a generic type T and T result. In our case, if you look at what we have in the IntelliSense, notice that first of all this extension method is being invoked on integers list. So that's why, look at that, it expects the input parameter to be integer and it should return boolean. Okay, so this expression right here is now going to be operated on each of the element that is present within this sequence, within this collection. So that's why if I hover the mouse over this x, look at that, it's inferred that the type of x is integer. And this lambda expression right here should be evaluated to either a boolean true or a false. Now x mod 2 double equals 0. So this is going to be either true or false, right? So the lambda expression that we have right here confirms to the signature of the function that this method expects, right? Now, what do you think is going to happen if this lambda expression doesn't evaluate to a boolean true or false? We will have a compilation error because delegates are type safe function pointers, meaning the signature of the delegate must match the signature of the function to which it is pointing to, right? So now instead of x mod 2 equals 0, instead of that expression, if I say x such that x plus 2, so that's also an expression. But what are we doing here? We are adding a value of 2 to x, to another integer. So what will be the outcome? Another integer. So this expression right here is actually going to return an integer. That's why we have a compilation error right away. Look at the red squiggly. If I hover the mouse over, it says cannot implicitly convert type into bool, and that makes sense because this lambda expression is supposed to be returning a boolean, but it's returning an integer, and an int type cannot be implicitly converted to boolean. Okay, right. Now, since this is a method that we need to pass, essentially at the end of the day it's a method, right? Now here we are using a lambda expression. Now instead of that, we can also create an explicit func and then pass it. So what type of func is this method expecting? A func int comma bool. So what we can do is create func of int comma bool, and we can give this any meaningful name. Let's call it predicate equals, and we specify our lambda expression here. So what are we saying? So this expression now is going to evaluate true or false. So input parameter here, x will be integer, and this is going to return true or false, so it confirms to the signature of this func. And then this is what this where extension method expects, so we can pass that here, and when we run this, we get the same output, all the even numbers. Or what we can do, we can create a separate function, then pass it to this method, something like let's create a private function because we are going to use that just here, and then let's make it static, and this function should return boolean. Let's call it isEven. It should expect a parameter of type integer. If number mod 2 equals 0, then return true, else return false, right? And then we can pass this function to this where extension method, which means we can get rid of this one, and we can say where number such that isEven, and we pass number to that. Okay, so when we run this, again we should get all the even numbers. Now again, this logic right here doesn't have to be that long. You can simply either say return number mod 2 equals 0. So again, this expression is going to return true or false, and that's what get returned to whoever is going to call this function. So again, when we run this, we should get the same output. Alright, now if you are from a SQL Server background, you might prefer to write queries that look much like T-SQL, and that's possible with LINQ. So let's see how to write queries, LINQ queries that look like transact SQL queries. First of all, let's get rid of this private method. So we write the from class first, from num. You can give this variable any name that you want, from num. In, what is the source? Numbers. Where number mod 2 equals 0. Now when I hover the mouse over, look at this. Numbers num type is inferred as an integer because it's operating on a list of integers, right? And then what we want to select all such numbers which are divisible by 2. Okay, now if you look at the transact SQL query, we first write the select clause, right? But with LINQ, we first write the from clause. So this LINQ query looks much like a transact SQL query that is reversed. So when we run this again, as you might expect, we get only the even numbers printed. Alright, now if you look at the where extension method, it has got two overloaded versions. The first overloaded version expects a func the input parameter is integer, and it's going to return boolean. Now if you look at the other overloaded versions, look at the func. It has got two parameters of type integer. So the first int here, that represents the number, each number within this sequence. What is the second int parameter? The second int parameter represents the index position of each element within the sequence. So the index position of 1 is 0, the index position of 10 is 9. So for some reason, if we want to retrieve the index position of each element within that sequence, we can make use of that second int parameter. Okay, let's actually print, all even numbers and their index positions within this array, within this collection. Now if you look at the select extension method, so there's another operator, select. Now again, this select function has got two overloaded versions, and they look pretty much similar to the where extension method. Again, look at the second overloaded version of the select method. It has got two parameters. Again, the first int will be the actual number. The second int parameter is the index position. Now, what is the purpose of the select extension method? Now, we'll discuss in detail about the select extension method in a later video session. For now, understand that we use the select extension method to project new types. Okay, we'll discuss in detail about it in a later video session. So what I'm going to do is store the actual element and the index position of each element in variables. You can call it x, y, a, b, whatever, but give them meaningful names. So I'm going to actually call this num, that's the actual number, and the other one index, such that what I want to do is project a new type, a new anonymous type. If you want, you can create the type, but we don't have to do that with LINQ. So what I'm going to do here is specify one of the property as number, that is going to store the actual number from this collection. And I'm also going to create another property called index, which will store the index position. So index. Okay, so here we are using the select extension method. And at the moment we have a compilation error here. That's basically because now look at this. What we are selecting now from this numbers collection is no longer an enumerable of int. We are actually projecting a list of anonymous type, which has got these two properties, number and index. So if I actually hover the mouse over this select, look at what it is returning. It is returning anonymous types, which has got two properties, number and index, both of type integer. Okay, so now what is the name of that type? We don't know, right? Because we're not specifying whether if it's a new customer, new employee. Now we don't know the name of that type. It's an anonymous type, a type that does not have any name. But what we know is it has got these two properties. Now anonymous types, to store anonymous types, we have a keyword called where. And let's actually call this result. Okay, so now this result is going to contain enumerable of this anonymous type. Okay, so what we can do now is loop through each item that we have got in this result, and again it's going to be where. So for each where, let's call it maybe item in result. Now what are the properties of each item that's present in result? Number and index. So what we are going to do is console.writeLine. So what we basically are going to do now is print each number and their index position. So console.writeLine item dot number property plus, so notice that though this is an anonymous type, IntelliSense still shows the properties that are present on that type, right? So item dot index. So when we run this program now, we should get all the numbers and their index positions. Look at that. The index position of 1 is 0. For 10 it is 9 because the index starts from 0, right? But what is our requirement? We want only the even numbers, right, and their index positions. So what we can do now is apply the where extension method. So where, now we can say number such that, so again here you can give the variable that you use here any name. For example, I'm going to say x for x such that x dot number mod 2 equals 0. So what is this going to do now? This is going to filter out all the even numbers. So when we run this, only even numbers and the respective index positions are printed. Now let's say I don't want the even number itself, I want only their respective index positions. If that's the case, we can again say select x such that x dot just the index. And now when we say select x such that x dot index, we know that we are retrieving the type of index is integer, so we are going to get a list of integers back. So you can either use this anonymous type, but now when we look at this item will actually be an integer, right? So when we run this, it should print the index positions of all the even numbers 2, 4, 6, 8, 10. Alright. So now let's look at an example of querying the database table data and then filtering it. Now to do that, I have these two tables, departments and employees, and here is the SQL script to create those tables and populate them with sample data. I'll have the script available on my blog in case you need it. And what we want to do is we want to retrieve only the IT department and HR department male employees. So in the output, we first want to print the IT department name and all the male employees belonging to that department. And next, the HR department name and the male employees belonging to that department. And we want to do it only for IT and HR department. Okay, so we want to apply filter both on departments as well as employees. So let's see how to achieve this. Now first of all, let's add an ADO.NET entity data model to this project. So add a new item. We want to add ADO.NET entity data model. Let's call this employee model, and we want to generate the model from the database. Let's call this employee DB context. So this is going to connect to the database and retrieve all the tables, views, and stored procedures. And we are interested in departments and employees tables. So let's select both of them, and let's call this model employee model. Click finish. Okay, so now within program.cs file, let's create an instance of employee DB context. Let's call it context equals new employee DB context. Now what we want to do is retrieve departments. So context.departments, this should return us all the departments, but I'm going to use the where extension method and then specify where x such that x dot name of the department equals IT, or x dot name equals HR. So what is this where method going to do now? It's going to return only IT and HR departments. Okay, and it's going to look at that. It's going to return an I queryable of department. So IEnumerable of department, and let's call this departments. Now let's use a for each loop. So for each department, let's call it DEPT in departments collection. What we want to do is print out the name of the department. So console.writeLine, let's actually print text department DEPT dot name. So this should print out the department name. And then what we want to do, we also want to retrieve all the male employees within each department. So DEPT dot employees. Now on this employees, we can apply the where extension method, where x such that x dot gender equals male. So this should return us only male employees. So IEnumerable of employees equals that. And then we can use another for each loop. And then print out each employee name. So console.writeLine, let's actually print a tab space and then print the employee name. So employee name equals, so /t here is going to print a tab space and then the string employee name. Employee name equals, have the employee object, first name plus maybe a space and then employee dot last name. And then after we print out all employees, maybe we want to print an extra line, so that would do that. So let's go ahead and run this and see if we get only male employees within IT and HR departments. Look at that, within HR department we only have one male employee. Within IT department there are 3 male employees, and all of them are printed here. Alright, that's it for today. Thank you for listening. Have a great day.